Now we're going to take a look at transformations of rational functions. Just to refresh our memory, anytime you add or subtract a number at the end of our function, that is going to be a shift either up or down. -4 would shift our graph down 4 units. Now, once again, just to review, your parent function for a rational function is y equals 1 over x, and that graph looks like this. The x-axis and the y-axis are asymptotes. Your graph goes through this coordinate right here, which is 1, 1, and also through this point, which is -1, -1. So we can also transform these points as well. All right, so first thing let's take a look at is going to be a shift down 4 units, means that our horizontal asymptote is now going to be shifted down 4 units. Down here, a +3 is a shift to the left 3 units. So we'll have a vertical asymptote right here. And because there is no vertical stretch or compression, these coordinates will not, well, the coordinates will change, but how we get to these points will not. From the intersection of your asymptotes, you can go over 1 and up 1 to get a point that is on the graph. So if I start right here at the intersection of my asymptotes, I can go over 1 and up 1 to get a point that is on the graph, and that point would be located right here. All right, so our rational function is going to go right here. I can also go the other direction, diagonal to it, which means left 1 and down 1 to get another point that is on the rational function. And our graph comes from this asymptote going through that point and towards the other asymptote. All right, so let's investigate another one here. This is a shift down 2 units. So I'm sorry, not down, up 2 units. So that means our horizontal asymptote will be located right here. And there is no shift to the left or to the right, so that means the y-axis is still our vertical asymptote. This time we have a negative, which represents a reflection over the x-axis. So instead of our graph being in the bottom left and top right, our graph is now going to be in the top left and the bottom right. There's no vertical stretch or compression, so I can still get to those important points by going over 1 and up 1 for that intersection point. And I can also go down 1 and right 1 for that intersection point. And the graph is going to go through those coordinates towards the asymptotes and look somewhat like that. It's not bad for freehand. All right, the next graph, we have a shift up 1 unit. So we have a horizontal asymptote, which is also called an end behavior asymptote. And then we have a shift to the right 4 units. So to the right 4 units will be the location of our vertical asymptote. Now this time we have a 2. Well, what the 2 is a vertical stretch by a factor of 2. Graphically, that means instead of from my intersection, instead of going over 1 and up 1, I'm going to go over 1 and up 2. And that will give me a point that is on the graph. I also can go up 1 and over 2, and that will give me another point on the graph. And so my graph comes from this asymptote through these 2 points and then towards the other asymptote. And we can do the same thing in this quadrant here as well. From the intersection, we can go over 1, down 2, and over 2, down 1. That would give us a point here and a point here. So our graph comes from this asymptote through those 2 points and then towards the other asymptote. All right, next problem. Again, we have a shift up 1 unit, and so up 1 unit is going to be our horizontal asymptote. And then we have a shift left 2 units, so that's going to be the location for the vertical asymptote. It does have a reflection over the x-axis, so that means my graph is going to be located in this quadrant and this quadrant. And we have a vertical stretch by a factor of 3. So once again, from the intersection of the asymptotes, I can go over 1 and up 3 instead of over 1 and up 1. So over 1 and up 3. I can also go over 3 and up 1. That will give me 2 points on the graph. So over 1, up 1, 2, 3 would put me here, and then over 3 and up 1 would give me a point about right here. And let me put those in a different color here. And then drawing the graph, going through those 2 points and towards the asymptotes. I can do the same thing in the other direction. From the intersection, I can go over 1 and down 3. I can also go over 3 and down 1, and that will give me the location of 2 points for my graph. Going from one asymptote through those 2 points towards the other asymptote. Except, what's the problem? We said that we need to reflect this over the x-axis. Alright, so reflecting over the x-axis means we need to undo this. Forgot that part, my fault. So let's reflect. That'll be over 1, up 3, over 3, up 1. Right here. And then 1, 2, 3, down 1. 1, 1, 2, 3, right here. Hopefully you stayed here long enough to get the correction. All right, so that represents our reflection over the x-axis. It needs to be in this quadrant and this quadrant here. All right, and we have one last problem. This one is going to have a shift down 2 units. So down 2 will be the horizontal asymptote. Right 5 units will be the vertical asymptote. And we have a vertical stretch by a factor of 2. All right, so that means from the intersection of the asymptotes, we can go over 1 and up 2. That will give us a point on the graph. And we can also go over 2 and up 1. And that will give us another point on the graph. And in the other quadrant, about right here and down here. And that's a sketch of the graph for that quadrant.